Okay, so welcome everyone to another NIRx webinar. Today, it is really my pleasure to talk about something we've had in the kitchen for a while, and now we are ready to show to everyone, which is the Wings 2, or the NIRxWINGS2, as we like to write it. I'm joined today by Benjamin Peltzer, which I'm going to give a proper introduction in a few slides. Also by some of my team members who probably have their camera on. So if you would also like to have your camera on, you're completely welcome to do that. But if someone has their camera on, the chances they're a colleague of mine are really high. So you can all identify yourselves if you want to. All right, now we are NIRx, and if the okay, all the slides went through. Oh, there we go. We are NIRx. Who are we? We pride ourselves in offering cutting-edge solutions to researchers across the globe in fNIRS and more, as you will see today. We have been in the field for quite a bit, and if you've read fNIRS papers, you've probably read about us. We pride ourselves in providing the best support that there is out there, and also in helping people publish high impact research with fNIRS. These are just a couple of pictures of us, but if you see us around in conferences, you know who we are. Now, moving on, if you would like to keep up to date with what we are doing and where we are, and you know what else is new aside from the Wings 2 or other things that we're going to talk today, these are all of our socials. But if you're like me and you don't have any social media whatsoever, you can always use the pigeon mail or your email to receive emails from us via this newsletter. So this is the way to reach us if you don't do social media, or you just want a clean email. We email a couple of times a year. It's not those newsletters that every Monday are knocking on your door saying, hey, this is all the small updates. No, we will knock at your door every 2 or 3 months with some very cool stuff. So it's worth it. I'm biased, but it's worth it. Moving on, a few considerations. You are muted, but you are welcome to speak whenever we open for questions. So you can use the Zoom feature to raise your hand during the questions or anytime really, but usually we do questions in the end. But if you have an urgent question to be answered right in this second, we still would like you to use the Zoom chat or use the little thing to raise your hand. This is recorded and available in our webinars page, which also hosts on YouTube. So if you or a colleague misses it or a part of it, don't worry, we will send this to you. And if you have further questions or you just want to talk to us, you can also go to consulting@NIRx or support@nirx.net. These two emails, you will get in touch with us. So our presenter of today is a dear colleague of ours, Benjamin Peltzer, or as we like to call him, Ben. He is part of our innovation team here at NIRx, and before that, he was developing statistical analysis methods for fMRI, first as a grad student and postdoc, and later as an assistant professor in Singapore at the Nanyang Technological University. And since he joined NIRx, his focus is on really bridging the cutting edge methods of neuroscience into our products to make them even better. So it is really a pleasure to have you, Ben, both as a colleague and today. And before I pass the mic to Ben, why Wings 2, right? We have a Wings 1, and now we have a Wings 2. The idea here is that the Wings 2 is the successor of the Wings 1 with collected feedback from you, from the community, and from even ourselves, with upgrades to sensors across the board, and also with something that I think is very cool and I want to mention is very high-tech, flexible ports that are kind of smart. Ben's going to tell you all about them. And yeah, although it is an upgrade of the Wings 1, the mission remains the same, which is to elevate your fNIRS research with covariates that are so important. The more papers come out, the more we see that collecting extra physiological covariates is a very important thing. So the mission remains the same, which is to elevate your fNIRS research. If you already have questions for this webinar, we welcome them. If you would like a dedicated demo or to, for us to show it working in your specific research scenario, feel free to drop us an email and we will get in touch with you. We will be so happy to show you. Now, I have extended myself for long enough, so I will pass it over to you, Ben, and I will mute myself. So there you go.
All right, perfect. Yeah, thank you, Gio, for that introduction. Yeah, I'm super excited to talk about the Wings2 today. I want to start off with a brief just overview of what we're going to cover in the webinar today. So first up, we're just going to have like 2 slides of a little bit of the theoretical background, why an fNIRS company is sort of playing with physiological devices at all. We'll talk about some of the key features of the Wings2. Then we'll go through a live demo. So I'll throw it back over to Gio and the team in the office. We'll talk a little bit about ways to think about optimizing data quality. The Wings2 is really good. So for the most part, if you follow the instructions, you don't then you're done. But just in case, anything isn't quite up to par, we'll talk a little bit about what might be going on and how you can fix it. We will cover some example applications, time permitting. So again, sort of returning to this question of what can you do with physio data if you're an fNIRS, sort of fNIRS first researcher. And then we should have some time at the end for question and answer. All right, just like I said, starting off with some of the theoretical background. The 2 main ways that researchers might want to combine peripheral physiological data with fNIRS. The first is that you primarily care about fNIRS for its own sake. You don't necessarily have any particular use for physiological data in terms of answering questions using that data. But you want to make sure that your fNIRS data is as clean as possible. So that's one possibility. And the other possibility is that you actually think that the physiological data can help you to answer the questions that you have, that you're nonetheless primarily using fNIRS to answer. When it comes to the first of those 2 use cases, the assumption in all sort of functional neuroimaging, including fNIRS, is that we're focusing on the functional brain activity. That's what we want to measure. That's what we're interested in. That's what our questions are about. Let me go ahead and turn on the laser pointer here in case I need it. So you can see here, this is from a publication by Taxidis and all, actually Taxidis and Schulkman, and they break down the different potential sources of what we're measuring in these different ways. So I'll talk about those in a second once we get to the reality. But again, to focus in on what we're trying to measure, we want to look at evoked neuronal activity. Obviously, if it's neuronal, it can only be coming from the cerebral compartment, not from the extracerebral compartment. So that's what we're trying to get. One challenge with fNIRS, and again with all sort of neuroimaging technologies to differing degrees, is that we are measuring, our signal is measuring more than just that neuronal activity. So it's reflecting other sources of signal. So for instance, we are also getting systemic activity that's in the cerebral compartment as well as the extracerebral compartment that's evoked. And then we're also getting non-evoked or homeostatic influence of neuronal activity as well as systemic physiological activity, again, cerebrally and extracerebrally. So the issue is we want to get to this, upper, like this closest cube of just neuronal activity. But we have this other sort of these other influences on our data. As we'll see, measuring the peripheral physiology is one potential way of addressing that issue. So this is an example of actually using a different approach to correct for the peripheral physiology. And it shows how the oxygenated and deoxygenated hemoglobin plots look before and after applying some cleaning, and you can just see that the hemodynamic response looks more sort of standard after doing the cleaning. So that's what we want to do by collecting the physiological data, is just clean up and isolate the activity that's specific to the neural activity. The other possibility is that you want to jointly analyze fNIRS and peripheral physiological data. So we'll go through an example later, but one example of a way that you could do that would be to take your raw physiological data, potentially to derive some features from those data to process the physiological signals in different ways. For instance, to get indices of sympathetic or parasympathetic nervous system activation. One thing that you could do with that would be to derive states on the basis of the physiology. So looking at when someone is in an activated versus sort of deactivated state, or aroused versus a non-aroused state, based purely on the physiology. And then you could look at how fNIRS activity, potentially across different tasks, differs as a function of the physiological state that a person is in. So by using the physiology, you can determine, again, potentially how cognitively aroused the person is, and see what influence that has on the brain activity. Okay, like I said, we'll come back to that later and go through a published example in more detail. But for now, I want to get into the features of the WINGS2 and then into the live demo. So there are a number of updates to the WINGS2. First up is this the NIRx BioLink sensor port system that Gio mentioned at the beginning. What this does is it gives us these completely interchangeable plugs for all of the sensors. So whatever sensor you're plugging in, if it's with the NIRx BioLink, again, these are sensors obviously that we're going to be supplying, then you can plug them in any of these plugs. It's completely interchangeable. It gives you a lot of flexibility in terms of the exact sensor setup that you want to implement. A second improvement is in terms of the cable management. So now when you want to add a new cable, it's really quick and easy. So there's just that single plug for a single sensor, and you don't have to worry as much about different plugs getting tangled. You can even plug these in and out pretty easily, just one-handed, if you need to. So that's improved. With the switch to these completely interchangeable ports, we've updated the visual differentiation of the different sensor systems. So each cable you might be able to see here is labeled. Respiration, EXG, and so forth. Obviously, when you get to the sensor end, you can tell which sensor you're dealing with. But here at the plug end, we also have different colors for the different sensors. Again, just to help you be sure that you're plugging the sensor into the port that you want to be plugging it into. With this new BioLink system that we have, the WINGS2 is also expandable. So as we release new sensors potentially. If they're using the same NIRx BioLink port system, then you will be able to buy those and they'll just plug right into the existing Wings 2 without needing any sort of adapter or anything else. And then you'll be able to collect those new types of physio data. We've also upgraded the cable shielding so that you get more isolation and better data quality. And we've updated the sensor technology for some of our sensors. So the temperature sensor, the GSR or EDA sensor, and the respiration sensor are all based on different sensor principles compared to the Wings 1. And all of the sensors have been refined. Finally, to talk a little bit more about the Wings 2 primary device itself, it's still ultra mobile. So it's under 200 grams, it's extra lightweight, it's very compact. So you can see here in comparison to a NIRxWINGS 2, it's even smaller. It still has wireless data transfer, so you just use a provided USB cable to plug in this the Bluetooth dongle, and that's how the data are transferred. So there's no wired connection. You can have the Wings 2 just completely on the participant, and they can be away from everything else. And again, to maximize portability, the Wings 2 comes with a carrying pouch and a belt, so that you can strap it right to the participant if you have a mobile paradigm. And the Wings 2 has about a 5-hour battery life, so you can run pretty long paradigms and be mobile the whole time. Finally, I've already touched on this, but the actual sensors that are included when you purchase a Wings 2, in addition to the mobility kit, the Wings 2 device itself, you get one EDA sensor kit, one respiration, one PPG or pulse oximeter, one EXG. So this is any bipolar electrical modality like EMG or ECG, and one temperature sensor. So that wraps up the sort of preliminary part, and now we will go ahead and switch over to Gio's team for a live demo.
Sorry. Yeah, there we go.
Okay. So we have our participant already wearing a cap, and now we're going to go ahead and start the process of getting her the rest of the way prepped. So let me get my windows in order here. There is the Wings 2 device. We're going to go ahead and start the process. So I cannot see. Delilah, you're doing the actual. Yeah, okay, great. So Delilah is going to go ahead and take the Wings 2, take the dongle out, plug that into the cable, and we'll plug that into the NIRxWINGS 2. As you can see, Zoe's all kitted up to be maximally mobile. So using the backpack from NIRxWINGS 2, the dongle, yeah, just can tuck right there. Now we'll go ahead and make sure the Wings 2 is powered on. Okay, and Gio, can we check the dongle on Zoe's backpack and just see? Yep. All right, so it looks like we're green. We need to make sure that we have the device, the NIRxWINGS 2, connected to Aurora.
1 second, Ben. It's blue, but the camera's weird.
Quick thing, Geo.
Okay.
If we can spotlight Geo, so Cami, either spotlight. Thank you very much. That will help everyone
Yeah.
see.
Perfect. Yeah. So the color is just not coming through properly with the camera, but Geo is saying that is a blue LED. So that means we should be ready to transmit data, that the Wings2 and the NIRxWINGS2 are talking to each other. Okay, let's go ahead and start setting up some of these sensors. So the first sensor we're going to do is going to be the respiration sensor. The order only matters insofar as if you need access to, let's see, I'm getting an echo now. Okay. Yeah, if you need access to to the body, basically with the other cables out of the way. It looks like we might have frozen in the office here. Okay, Geo is on the fly troubleshooting with that camera. I can go ahead and talk through the process a little bit. Hopefully they get the technical issues, the camera issues figured out. But yeah, so we're going to start with the respiration sensor. This is, in contrast to the Wings1, a belt-based sensor. So it's just a stretchy fabric belt that you open up and then can affix using Velcro. And you can wrap it around the participant's chest or abdomen, or in principle both. You get two belts included, but only one set of cables. So if you need to do a multi-belt setup, then you would need to contact NIRx for to get that sort of extension. It looks like our camera is back on.
Sorry.
Yep. Excellent. So all right, so we're seeing the belt. Delilah, you can go ahead and start wrapping that belt around Zoe's chest.
So
Again,
we're doing Zoe's belly because she's a belly breather.
Yeah. So, and that's definitely something that you'll want to figure out. Zoe is wearing pretty good clothing also for the respiration belt. The thicker or more layers of clothing that a participant has, the less well it's going to work, just because you've got sort of more degrees of freedom. The way that the belt works is as the chest cavity or the abdominal cavity expands and contracts, the belt stretches more or less. Yeah, exactly like Zoe's demonstrating. But if there's a lot of bulky clothes, then the change in the abdominal cavity doesn't translate to the belt. So thinner, snugger clothing is good. Delilah's going to go ahead and now plug, just snap these plugs onto the snaps. In general, I see a question here. I'll go ahead and answer it. So we're attaching the breakout box for the respiration sensor, and let me get my little cheat sheet up. We're going to plug this into into port 7. So again, where you plug these sensors into doesn't matter. The Aurora software is going to detect what sensor is in each port. In general, you're going to want to keep the same order from subject to subject. We're doing a special order just for the purposes of visualization later. So we can go ahead and move on to the next sensor, which is the EMG. The EXG sensor, in this case, we're using it with the EMG application. So we've already got the disposable electrodes snapped in there, and we'll just go ahead and peel off the backing and place those onto Zoe's right forearm. Here we're targeting just the big muscles that are involved in sort of clenching and relaxing of the fist. Obviously, if you have a specific effector, then you'll need to know where that muscle group is. We're going to place the reference electrode then over a bone. While Delilah is doing that, you don't necessarily need to know what kind, like how your participants breathe beforehand. Most people are going to get movement, in the chest and the belly. So if it's really exaggerated, then maybe it makes a difference. But for the most part, you can probably just choose one or the other. And if you're going to choose one, it's usually the chest. So you can see Delilah used some tape on the amplifier there for the XG system, just to keep the cables from pulling. And now she's going to plug the other end of the cable into port 5. Yep, quick and easy. Okay, moving on to temperature. So we're going to set up the temperature sensor on the back of Zoe's left hand. And for this one, we're just going to use a little bit of tape on the amplifier. So you'll see it in just a second once it's in frame. And then to get the tip, okay, so yeah, cable management, and then to get we want the tip of the temperature probe to be exactly pressed up against the skin to have good contact with skin. So we're just going to use some tacky sports wrap. So this is not sticky. There's no adhesive because we don't want to risk damaging the sensor itself. But this will just help keep it snug against the skin. We'll plug the other end of that sensor into port 6. And our next to last sensor actually is GSR or EDA. So that comes with these finger straps that you can see, Velcro finger straps. We need a little bit of isotonic gel on the actual metal part of those straps beforehand. And then we'll be putting those on the left, on Zoe's left hand. We'll do index, middle finger. You get slightly better signal if you use the distal phalanx, but for participants with skinny fingers, the sensor might slip off there. So if you're concerned about that, if you have a mobile paradigm, or just if you don't need sort of the highest amplitude signal possible, then that intermediate phalanx that we're demoing here is perfectly fine. And we might want to, do we have any tape on the amplifier or anything just to keep those cables? There we go. Yeah, so let's, again, just make sure that that's stabilized so that even as Zoe moves her arm around, for instance, it's not going to tug those sensors out of place. And then that's going to plug into port 8. You can see that the plugs there are directional, but it's really obvious which direction. I mean, if you try it once and it's wrong, then you just flip it over quick and easy. So now we're plugged in 5 through 8. And the last sensor we'll do is the PPG, which plugs into the front. It has a dedicated port, and we'll just clip that clip onto Zoe's ear. Okay, meanwhile, Gio, I think we have, do we have Aurora up and running and with the device connected? Yeah, go ahead and plug the PPG in. Okay, that means yes. Thank you. Excellent. Okay, so I think now let's zoom out real quick, Gio, to show Zoe. Okay, there's our participant all prepped with 5 sensors, and that took, I think, under 5 minutes maybe, so pretty quick. And we can switch over now to Aurora. All right, so while Gio is making the switch, for the demo today, we're just going to do a couple of simple tests to show how the procedure works. To recap up to this point, what we've done is connected the Wings 2 to the NIRxPort 2 using that Bluetooth dongle, and then turned on the Wings 2 rather. The NIRxPort 2 is now on, and then we plugged in all the sensors after attaching them to the participant. So we've got our device. This is looking in principle promising. There we go. So we need a configuration file that has biosignals enabled. This one hopefully does. What's an important thing to know is as soon as you lock in that configuration file, that's when Aurora does the detection of which sensors are in which ports. So from this point forward, we couldn't make any changes. We couldn't swap which port a sensor is plugged into. But up to that point, it's totally flexible. So let's go ahead and do signal optimization. And this is just going to work the same as always. Obviously, for this demo, we're most interested in the physio data. So we're not going to worry too much about what we get out of the signal optimization. But this process is exactly the same as you're used to. So if you don't normally use the Wings 2 and you're introducing it, this step doesn't change. So we're just going to go ahead and let the signal optimization run. And as soon as it's done, we can continue on. And everything's looking really great, almost all green. So I would say we can go ahead and start recording. Perfect. So if you saw very quickly there was an extra tab on that setup box that you can do some naming of the channels with. Again, that's covered in the user manual, so we don't need to delve into it here. fNIRS data is looking good. Let's switch over to that biosignal tab. So if you're not used to using the Wings 2, again, we've got a new tab here. Let's go ahead and actually scroll all the way down to start. Let me get my window back. Okay, up a little bit just to get the, so just above respiration and GSR. Let's get those. One pair lower, if you could, Gio. Perfect. Okay. So the demos that we'll start with, we're going to be focusing on the respiration, GSR, PPG, SpO2, and heart rate. One thing that we normally need to do is there's a zeroing procedure for the respiration belt. In this case, we actually don't need to necessarily do it. What you want to see is that your signal should be oscillating around 0. The process for that is really straightforward. The participant just sort of has an intermediate amount of air. So like in between inhalation and exhalation, you press that button for about 10 seconds and it zeroes that axis. So we can see that that's already working. We're just fluctuating around 0. And then we'll do these tests that I mentioned for all of the other signals just to demonstrate that everything's working properly. So let's go ahead and we'll start with the Valsalva maneuver. Let me check the scale here. Yeah, the window scale looks good. We are showing everything in filtered mode. That's fine. If there's issues, we can switch back and forth between filtered and raw data mode. But the Valsalva maneuver is a way of evoking a GSR response. So I'll go ahead and count down 3, 2, 1, and then Zoe is going to do the maneuver. And that was it. So you can see that the GSR plot there in the upper right-hand corner, you get this nice skin conductance response. You would also see the change in her respiration plot. You also see that her heart rate bumped up at the same time because, again, all these, all the physiological systems are connected. So we're seeing the effect of that in multiple plots at once. So that's good. This is also a thing you can do if you want to check your data quality, especially for the GSR. Have the participant do a Valsalva maneuver, and you can make sure that it's working properly. We can go ahead and move on to a respiration test. Let's do a hyperventilation. And when I count down, Zoe is going to hyperventilate, and we should see that show up at least in the respiration plot. So in 3, 2, 1, go. So you can see in the upper left-hand plot, that's our respiration plot. It looks drastically different. So we get the same sort of periodic oscillation. Yeah, sorry, you can stop. But the period or the frequency of the oscillation is much higher. You also see that, again, her heart rate is now on an upward trend as her cardiovascular system is responding to that. We also see it in the GSR plot in the upper right-hand corner. So again, that's looking good. Respiration signal looks nice and strong. Let's test EMG. So for this, now we can scroll the window back up so that we just get those exactly. So I'm going to count down, and Zoe is going to squeeze her right hand, and we should see it in that EXGA plot. So 3, 2, 1, go. And stop. Okay, so there in that upper left-hand plot, again, we can see very, very clearly the signal looks drastically different when she's doing the squeezing compared to the other periods of data collection. I should point out that all the filtering options that we see here on this tab only affect display. And in fact, the filtering might not be optimal, especially for EXGA because it's so flexible. So that if you're used to doing EMG research, that might not have looked exactly like what you're used to, but rest assured that the raw data that we're recording is not affected by the filtering that's being applied here. So you can filter it however you want in post-processing. Lastly, let's test the temperature sensor. So Zoe or someone else is going to now blow hot or cool air onto that temperature sensor. So I'll count down, and let's do hot air in 3, 2, 1, go. There we go. You can see that upper right-hand plot, which is temperature trending up. It's not a huge effect because we've got that sports tape. Oh, there we go. I think we've removed some of the sports tape or just, gotten closer so that you can see the effect is bigger. There we go. So you can see as Zoe blows on that temperature sensor, we're getting that strong response in that upper right-hand plot. Also, of course, normally you want isolation between your sensor and the environment. So we're only doing this for the purposes of the demo. In a real situation, you're probably going to have some extra layers there so that it's not as affected by the environment. Okay, and I think that's everything we had planned for the live demo. So I'm going to go ahead and switch back. Gio is doing a finger, so thumbs up. Okay, good. I think that means we're good.
No, yeah, 1 second. I just wanted to show, if you stop sharing, Ben, for a second.
Yeah. Yep.
That the triggers, so if any triggers come in via TTL, LSL, or whatever is your flavor, whatever triggers come into the fNIRS signal, they will also go into the wing signal, they go into the fNIRS signal at the same time. So completely synchronized by the dongle, by the dongle that we put in the wings. So
FNF2?
Yeah.
Yeah, exactly. So it's all recorded in the same SNRF file, and you can see that everything's automatically synchronized, which obviously is one of the big advantages to having an integrated sort of hardware platform.
Thanks, Ben.
Yep, thank you, Gio. And now I will continue on. I went a little bit too slow in the beginning, so I will skip a little bit here at the end, but that's fine. If people have questions, then maybe we'll cover some of the information anyway. So the data quality, I mean, as you could see just in that demo, again, we didn't do anything special when it came to sort of the setup. That was just, you know, a very quick setup, and we nonetheless could see strong signals in all the channels. If you do have poor data quality, the top culprit is going to be poor contact. For the on-skin sensors, that's going to mean just making sure that there's connection between the sensor and the skin. So for EXG, you need to prepare the skin, typically with a little rubbing alcohol, or at least a little water, and let dry. For PPG, EDA, and temp, the temperature sensor, you just need to make sure that these are snug against the skin without being too tight. So that's pretty straightforward. As we did here, you'll want to use tape as necessary to make sure that the sensor itself isn't being tugged, especially if the participant is moving. As I mentioned, for the respiration sensor, you want to have just very few layers of thin clothing and relatively snug fitting clothing, so that the movement of the chest cavity translates to the stretch of the belt. And lastly, for the snap-in sensors, if you don't get that snapped all the way in, so that the cable is not actually, you know, attached to the sensor properly, then obviously that's going to cause issues. And it's always a good idea to do a preliminary data quality check before you start your paradigm. With respiration, you can do a few different rates of breathing, deep breaths, shallow breaths. Just make sure that you're getting the expected changes in the signal. For PPG, or if you're doing ECG, you just want to make sure that you can see that typical pulse waveform. For EDA, you can just look at the baseline level, and it should be in this range of 1 to 15 microsiemens. Optionally, you can perform the Valsalva maneuver, especially if you have a question that relies on EDA data. For temperature, it should just be in sort of standard healthy body temperature range. You can do checks like the one that we did to make sure it's responsive, but it's not typically necessary. And for EMG, again, the default filters in Aurora are tuned more for ECG. So if you're doing something EMG focused, you can check those filter settings and then just have the person tense and relax a few times with the target muscle and make sure that that shows up as expected. Let me see. I think that we will hold off on all of this until we see what questions come through, because I want to make sure that people have a chance to answer their questions. Again, if there aren't very many questions, then we can, or if somebody asks a question, like, you know, to go through those examples, then we can loop back to that. So Gio, do you want to go ahead and yeah.
Yes, I'll jump back in just 1 second. My setup is overrun with demo things. There we go. Okay, I changed to my proper camera. There we go. So I believe we had one question already in the chat, but I'm pretty sure you addressed it. About what do we need to know in advance the type of respiration of our subject.
Right.
So pretty sure you addressed that one. Now, fresh one, could you discuss proper data cleaning procedures for each physiology signal? That's a deep one.
Yeah, that's so I think you know, we're making the equipment, but not the statistical procedures and so forth for doing something with the data. So it's beyond. I mean, we have a lot of expertise in the company dealing with this sort of data. And I think that if you approach the support team, for instance, they can at least point you in the right direction. You know, canonical references for dealing with these different types of data. In general, though, yeah, you're going to want to seek out like these sort of specialized publications or books or chapters that deal with those signals, because with at least five different modalities, it's too much to cover in the time that we have.
So yeah, throw the ball to the support team. We have a couple of selected publications to share, of course, about each sensor, and we would be super happy to share. Of course, you know, once we know also the exact application that you're doing, we would also be very happy to get that over, to send that information over. Okay, so I don't see more questions directly in the Zoom chat, but people, feel free to just unmute and jump in. Otherwise, I will jump to the questions that were asked previously during the registration procedure. So yeah, I'll give a couple of seconds and then I will read a couple of them.
Just very quickly, Gio, I saw that Jackson put his camera on. So Jackson, I don't know if you had a question.
No question. No question. Thank you. Everything okay.
All right, good to see you. Okay, question from Gufang. Since you mentioned that the second generation wings added cable shielding, is it correct to understand that the first generation did not have this feature? I am not sure we talked about cable shielding, but Ben.
I believe that's correct. I don't know if we have anybody from R&D, from the R&D department on this call who can jump in and confirm. If it's certainly the case, the shielding is improved with this generation. I don't know if that's to say, like I don't know how one quantifies the degree of shielding. It's not my background, so I can't say for sure what we had on Gen 1, but it's better now.
Yeah, I'm pretty safe to say that the first generation does have cable shielding. Maybe it's different cable shielding, but surely has some capacity of cable shielding, although I cannot tell you which specific. But thanks for your question. Okay, so some questions. Maybe I can answer even this one. If I want to collect physio data from 2 participants for a hyperscanning setup, can I buy more sensors and plug them into the same wings too? So I will start to answer the question, and maybe Ben, you do comments or more technical. So yes, it is possible, but our general recommendation would be to have 1 dedicated wings per participant, not only because we want you to buy 2 wings devices, but also because there are sensors which have grounding, for example, and shared grounding and considerations of that sort are tricky. Also, data structure is tricky because the way that Aurora does hyperscanning, you need to assign specific sensors to a subject. So it's gonna be less practical, and that's not really the NIRx way of doing things. Plus, some of the sensors don't really have 2 copies of them. So for example, the PPG sensor, we only have one connector for them. So it would be limited in that sense. But I don't know, Ben, if you have other considerations,
No,
or if the person that asked the question wants to complete their question.
Yeah, I mean, I agree with everything you said. It is possible. I think we have done proofs of concept with at least some of the sensors. So especially if you just want one sensor and you don't have to worry about the ground, and you know, you can buy the extra copy that you need of the sensor, for instance, respiration. There's still issues in terms of the proximity of the participants in some cases, I think, to avoid potential interference, but in principle, it's feasible. It may just be a little awkward.
All right. Then I will move on to some other questions from before. There were a lot of them, so I'm trying to pick different topics to try and give an overview. Someone said that they would ask questions during the webinar. So if you are here, this is your opportunity. Which units are the physiology data collected in, and what are the recommendations for? Oh, okay, so this is from Maureen. So I guess we have already discussed that. Sorry. How key consideration for experiments involving linguistic stimuli and its potential in cross-linguistic perception studies. This is highly specific. If the person that asked this question wants to give us a few more details about their research or what they're interested in, we would be happy to answer. Otherwise, I think for linguistic experiments would be interesting to measure. If you're interested in emotional response, for example, you could measure the GSR, or having heart rate variation in general is a good covariate, but honestly, not really my ballpark.
There's also a new question in the chat, which is one that I think we got potentially offline as well, which has to do with comparing Wings and Wings2. And some of these are going to be less comparable than others. So the GSR is sort of a fundamentally different measurement approach. So that one I would definitely stay away from trying to compare. Some of the others, it depends on what your analysis is. So temperature, obviously, you've got, the units are the same, and in principle, even though the measurement principle is different, you could compare, but I mean, under no circumstances would we say you should like switch between, in the middle of a study. That would definitely not work. If you just want to get like the big, 30,000 foot view of trends in the data, I think you can do those comparisons for most or potentially all of the sensor systems. So if you're looking at, rates of skin conductance responses or something, like if you've abstracted the data in the right way, you can do comparisons. But in general, we would say tread carefully and, probably check distributional assumptions, just like do the results you get from Wings and Wings2 have the same distributional characteristics, things like that, if you're going to try making those comparisons.
All right. I think we have time for one or two more. So I encourage people to ask their questions. Reading the next one. Has this been utilized with developmental populations? If so, are there any differences or limitations? I can tell you that it was designed not thinking of developmental populations in that sense, especially because of the size of the sensors, especially the Wings 1. The Wings 2, I think it also holds true, but it's more flexible in the sense that more sensors can be added, can be adapted. For example, the respiration belt, it's a size difference, and electrodes for EMG or any other potential EXG. It's also a matter of size of electrode. But the general, let's say the general design did not have developmental populations as the main subject of interest. Open for comments, Ben. Yeah.
Yeah, that's right. I mean, there's a lot of there's a big field of developmental psychophysiology. So in general, people are doing this kind of, are using these kinds of sensors in developmental populations for sure. I'm sure that there's considerations in terms of, for specific sensors, what you might need to change in those populations. In general, like Gio mentioned, you might need to order, and we can help you with that, a smaller size belt, like a child size belt for respiration, and you might want to adapt especially the disposable electrodes, just because they're big, they're adult sized. So depending on where you're applying them, they might be awkward for a child. But in principle, everything should work. And there's actually a publication from Pinney et al. That showed that at least short channel regression is, which also is a way of dealing with sort of physiological contamination, is helpful in developmental populations. So there's that use case is definitely supported in developmental populations.
All right, thanks, Ben. I see that the person with the linguistic question has commented. I believe it's a matter of us having to collect a few publications to answer that question for ourselves and then to answer to you. So we will follow up on that.
Yeah, the one thing that
Yep.
comes to mind quickly is if you're talking about language production, if you have currently any issues with motion artifacts, for instance, depending on what kind of language production the person's doing, you've got, obviously muscles involved in speech production, in the general vicinity of the cap. So if that's an issue you have, then you can probably do some EMG and deal with that. But yeah, like Gio said, we can look for more established sort of use cases.
And then maybe to close it out, as we have 1 minute, and there's just so many questions that I feel bad not addressing them. An easy one: can you use the Wings2 while plugged into a power socket? And the answer is no. It cannot be used while being charged, unfortunately. Not like the NIRxPort 2. So I picked an easy one.
But it has
Yeah.
a 5-hour battery life. So unless
Yeah.
you're doing very long data recording paradigms, then it should be good enough for most people.
Yeah, then with that, we have reached our time. But once again, as I said in the beginning, you do have our contacts, consulting at NIRx and support at nirx.net to contact us or whatever other method you feel like. We are always open to talking to you about your research and any other questions you might have about the Wings2. Thank you so much, Ben. Thank you so much, everyone, for participating and for sending your questions. Thank you to the people that helped us with the demo. So Zoe, Dalila, and Marina, who are not in the frame right now, but are sitting here and nodding. So yeah, thanks everyone, and have a nice rest of your day.
Thank you, Joe.